again, my friends. Welcome back to Leopard Street. No cat-related shenanigans in this one. She's not been down here today. Basically, I relocated. I work from home most of the time. I'm fortunate in that respect, so I'm grateful for that. It got quite warm upstairs. The powerful PC I've got that sits upstairs, I've got a Dell Alienware thing that lives upstairs, has got a 1.5 kilowatt power supply in it. So it's like having an electric bar fire in a room. Now, when it's quite warm, my better half has a similar machine that she uses for game streaming. So hers is screaming for mercy most of the day. So upstairs got quite warm. So I brought my work laptop down. I relocated down here for a couple of days. Smudge decided to join me. Misty came down here actually a few times as well, but I didn't get any video of her. Next time she comes down, I'll have to try. Yeah. So we're looking at in this one. If you remember from a few recent videos, I'm filming this afterwards, I've thrown it away. I had a problem with a PCF8575 sending spurious signals back, block occupancy stuff not working, it was going haywire. This was when I was trying to set board J up over there. I was thinking, And eventually I traced it back to, it is the chip. There's just a faulty chip. I looked at the symptoms, and I've got two others on the layout that are faulty as well. They're not connected to anything yet, but they need fixing. So what we're going to look at today is a board to test them. So I'd have to build them, fit them, find out whether they work. I'm just going to connect some switches, I'm going to connect some LEDs, and we're going to test them. And that way I know if they're good. The moral of the story here is I tested the output side of them before. Could they drive a relay? Yes, they can. Didn't test the inputs. I naively assumed they would work, and if my hardware could connect to it, we're all fine, it's all gravy. Yeah, no. Moral of the story, test everything. So, yeah. Anyway, we're going to look at that. After that, we're going to have a quick little look at the turntable back here because I found out what the cause of that weird buzzing sound was in the last episode. Yeah, it is weird. Anyway, we'll have a look at that in a minute. First off, to the desk, and we're going to have a look at this PCF8575, and we're going to build a test board. So, yes, this is Leopard Street. Okay, so a few videos ago, I showed this little beastie. PCF8575, this one doesn't work. Well, since then, I've got more turn off. I've got another 10 of them. So what I need to do, it's simple enough. Take these out of here, put these little bits to one side because I don't need them. I need to assemble these and fit them. I want to test it first. Now, call me cynical, but since I've had some of these that didn't work, I want to test them. So to test it, there's a couple of things I need to do. So here is Mr. PCF8575. And off to this side, I have int. I've got SCL, SDA, B+, and ground. So interrupt is an output, clock is an input, data is an input, and an output. Don't need to go into how that works. And there's then these two 10-pin connectors. Well, the way I use it, the ones on this side are inputs. And the way you make an input work on one of these things, I'm only going to draw one of them. This sits at a high logic level internally. So if you want to take that to a low logic level, it's actually remarkably simple. You put a switch, connect that to ground, goes to low when you read it back. So you write into here a 1, and if it's like that, when you read it back, it'll be a 1. If you close the switch, when you read it back, it'll be a 0. Brilliant. That's that side. This side, here are outputs. Now I use them to drive relays, but in order to test this, what I'm going to do is I'm going to put an LED there, and it has to be that way around. It needs its resistor, which I'm going to use a 1K, and it comes up here to V plus. Now, you write out to that a 1. So V plus, no current flow, light is off. If you write a 0 to that, current flows into this thing and away, and the light comes on. Excuse me one moment, I'm just checking something. I'd have a 3D printer printing something that's making weird noises, but it does appear to be working. Right. With this as a 1, these things really don't output very much current. So it will drive an LED, but it'll be dim. This way it'll be nice and bright. So what I need to do is I need 8 switches. And the really easy way of doing that is to use one of these, which is 8 switches. On connects the 2 pins together, off switches them off. So I might actually put it that way around. So that is effectively becomes a 1, that becomes a 0. Doesn't really matter, but that's 8 switches. Not quite as convenient as having 8 push buttons, but a damn sight smaller. Over here, I've got LEDs. Now these are square LEDs. You can use round ones, but if you use these square ones, you can do something a bit different with them. If I can get it to go in the holes. I've got a couple of different colours. I'm just showing this, it doesn't matter which way around these things go. But what you can do, get in the hole, is they will sit next to each other. Now round ones you tend to end up having to leave gaps between. If you're using 5mm ones, you have to leave quite large gaps. These will just sit next to each other. So what I can do, strips go that way, is I can put a connector up here, or more probably I'll probably put the connectors towards the middle. Put them something like that, line them up. I can drop this little board in between, so if I space them out a little bit more, because that's what I want to be able to do. Something like, I'll get them in there, something like that. That'll sit in the middle. Right, I'm going to bring this one down a bit. Now, if it's one of these boards, I could just sit it off to the side, but then all I have to do is get one of these cables and go from there to there. Brilliant. And now that pin links to that socket, and so on and so forth. What it means is I can test these things. All I've got to do is stick these connectors on them and I can test ones. If it doesn't work, it doesn't mean I've lost that connector, but I don't have any other way of connecting them up. So I can do that. Down here, I can put that. And on this bottom edge, I need to link all these pins together. Well, that's a doddle. I'll just bridge them with solder on the back. Easy. This board provides me with power and ground, and just checking which. Ground is this pin here, and power is that one. So this one here, these are going to connect to the outer line, connect onto that. Up here, what I'll do is I'll stick a little array of resistors, and I'll put a bunch of these in. So, let's power up the soldering iron and make a start. And obviously I'm going to have to then connect this to something in order to get it to work, but that'll probably do. So what I'm going to do is I'm going to build the bottom half of this first, because that I think will be the easy bit. I mean, I could even move that. Can't really move that up a bit, but I can put it there. Done. So I'm going to turn that over like so. I will need to take out those and balance that on there. I will need to put holes between these. Don't particularly think that's a huge problem. So, soldering iron. And I did have a suggestion from somebody. Thank you for what to do with this blasted cable. What was suggested... Solder gun. That's over here. What was suggested was put a heat gun on it and just straighten it out a little bit. I must say, I'm actually quite tempted to do that. Right, so I'm just going to move my light around. I'm knocking the camera there. I should put that back. Move this around so I can see what I'm doing, or at least try to. And we're going to come in here, and I'm going to stick that leg there on. It's flowing nicely. And that leg there, a bit more of that, onto there. It's flowed nicely as well. So, and if you're soldering things like this, it's often not a bad idea to do the two ends first. That's flown nicely. I'll do the opposite corner down here. And these ones down the bottom, I actually want to blob all together. So I'm going to get this assembled, and then we're going to come back and we'll test it. So I'll catch you in a mo. Okay, done. So I've assembled a new one of these. It's on the same address, OX20, as the others. This is one of the new batch. I'm hoping this one works. Here's the board. So as you can see, we have 8 resistors, 8 LEDs. Resistors are all commoned along the back. Basically, I just bent one of the wires along. And it is soldered onto this pad here, which provides the positive. Positive and ground are common from one side to the other. Switches, the resistors have had tracks broken under them. The LEDs have had tracks broken under them. As you can see, I've got them in a nice little line. This side, switch, tracks broken. There's a little bridge commoning it to ground. Ta-da! So what I need to do is plug this in. Now, fairly obviously, this isn't going to do anything at the moment because it's not connected to anything. So I'm going to solve that in a second. I'm just going to get these wires into there. So that, yeah, that now sits in there, and twisted these wires around. Never mind, let's take this out. Get that out. Sorry. That just goes over and goes in like that one. Right. Basically stops it from falling apart. So put that to one side. What I now need is my testing rig, which is here. Now, what this isn't going to do is replicate the switches here onto the lights. That's not what this board is programmed for. This is my normal testing board. So I'm going to unplug that and that just to get those wires out of the way. I'm going to unplug that. That one I'm going to test as well in a minute. I'm going to test this new one first. So that's going to go there. That is going to get plugged in. Now, let's make sure we've got that in shot. I'm going to fire this up. And then I'm going to start sending it some messages. But we're also going to have a little look. Go in there. Little heartbeat light should come on in a sec. There we go. And a servo's moved, which has told me it's all powered up correctly. So, what I need to do is bring that. Okay. So what I got here is MQTT Explorer as usual, and down here somewhere Z block. So this is my switched inputs. So what I need to do, and what you need to watch, is these ones here. They'll say inactive. This is good because the ones that are these boards that have been faulty, they say active when they're not. So if I switch that one on, Z0 goes active. That one hasn't for some reason. That one has. That one has. That one has. Yeah, some of them are not going active. That could be dodgy connections. So they should all now be showing active. Let me just try some of those again. Turn them all off. All off. Right. Try again. So first one, active. Second one, no response. Active, active, nothing, nothing, active, active. Right, well, what I'm going to do is I'm going to cheat slightly, and I'm going to manually connect some of these other ones, because this will tell me if it's a switch problem or not. So if I put that, that's a ground pin. So if I come over here and just start connecting these manually, and connect them in manually, that one tells me it's not that end. Yeah, anyway, so some of those are working, some aren't. I suspect what I've got is dodgy connections somewhere. But as you'll notice, the LEDs are still all off. Well, the LEDs talk to turnouts. So if I come back up here, and what I need to do is say Z1 thrown. Light comes on. Now, it already said thrown, but it hadn't sent that. I hadn't told it to store that. So that's Z1. If I set Z2 to thrown, that comes on. Z3. And as you can see, as this is going, this is talking correctly. So this is sending out the signals nicely. Now, what I'm going to do in a minute is plug in the broken board, and we're going to see what that does differently. All right, Z7 thrown and didn't go for some reason. Z8. That one's gone. Why hasn't Z7 gone? If I had to guess, again, there's an iffy wire. Yeah, there we are. I've got a dodgy connection. Yeah, that's probably what's happened on the other side as well. So if I fiddle about with those, I might find, if I go back down here to Z block, I can get these things to, yes, register by fiddling with wires a little bit. The blue one is one of the ones that's not working. So press that end, press that end. Yeah. Anyway. Yeah, it's gone out again there. So here we are. Yeah. Anyway. That shows that's one of these things when it works. So what I'm going to do is unplug that. Unplug this. This is possibly why the wires are a bit knacked. Because I'm probably overstressing and plugging them in and unplugging them. Have to see. Anyway, so that's that. So what I'm then going to do is I'm going to plug the known. Ooh, if I can get these connected. These aren't normally this stiff. I'm not sure what's wrong with this. Come here. Right. The 10 ways are a bit stiffer than some of the others, but anyway, so that is good. I know that works, so I'm happy with that. So here I've got the one that I was having problems with on the layout. So I'm going to plug this in, and we're going to see what it does. And my luck being what my luck is, I'm probably going to find it works perfectly. But we shall see. So if I reset all of those switches, back down to nothing. If I can get a couple of them to work, I know the thing's reading it. The rest of it's then just it's my fault and a wiring issue. So tell that to reset. I'll have a little look. Now, you see what these blocks are doing? They're all over the place. Now, if I turn these on, all active. Now, if I turn them off again, which I'm going to have to use a tool to do, they come on, they start flickering all over the place. So, reset the board again, which is that one, not the other one. There you can see they go active mostly. Board comes on, and now they're just all over the shop. That's telling me the inputs aren't working. Let's have a little look. Yeah, a little look at some of the outputs. I can avoid. So I'm trying to. I've got a large amount of space to move the mouse around in, and every time I touch something, it presses against something. So we'll come up to here. Z1. We'll throw Z1. Light works. See, this is what was confusing me. Because these here, the output side of it's working. which before was all I tested. And that is entirely my own fault, because I assumed if part of this thing worked, yeah, Z7's a dodgy wire. There we are. So they work. It also rather incidentally shows some rather nice colours on LEDs. Hopefully that's showing up. So yeah. So here we have a little test board. I am going to do another one, because what I'm going to do is test this one that's actually built into the test board, because I think that's actually got exactly the same problem. Assuming I can get these blasted plugs out again. Right. So that I know is rubbish. So I'm actually now just going to throw that away. Because what I don't want to do is try and connect that to something to try and make it work later by mistake. So plug those into there, that into that one, and again reset. Have to do the reset because that's sort of how I know it works. So if I now say Z8 is D, that's come on, and again we'll go through them all and I'll have a look at the inputs. That one's still not working. 6, yes, 5, D. I mean, the ideal would be to have the 4. The ideal would be to have something I can just sit the little board on and have it make pin contacts, the sort of the little pogo pins that you get on some of the better trains. I don't really need to for this, so I'm now going to come down here. We're going to go down, find Z block sensors, and as you see, they're all over the place again. They're just constantly changing. So if I flick a couple of switches here, if any of them go active, they'll all go active. It's when they're off, they're just all over the place. So that tells me this one here is also knackered. So I need to change that. But there we have a test board. So yes, that's been something I've been meaning to do for a little while. I wanted to wait until I got some more of these through. So that works. There are, I believe, 2 more dodgy ones on the layout. Board L has got 2 installed because it's got more than 8 points. One of them doesn't work, so I'm going to be able to replace that. And board M has got one that's doing the same thing. Board L, board N doesn't have one installed yet, but I can now test them. Yay! Yeah. Anyway, catch you in a moment. Yeah. Quick update on the turntable. I've reassembled it. The assembly is exactly the same as it was the last time. The only slight change, I had to insert a little plastic disc. That's a printed one. It's a plastic washer. The wires that come off the bottom of the turntable hang down quite nicely, but they don't rotate. They're the fixed part of the slip ring. So the table rotates. That's fine. The coupling for the stepper motor rotates. That's fine. That's got a little gap in it, and that's its expansion gap that you tighten up. As it's rotating, one of the little wires went ding into it and gets caught. So I've just put a little washer on the top, and it just keeps the wires spaced out. Now, in the last video, I'm going to put this on top of the thing, so you'll hear this. What I did is I powered this up using 12 volts, and we had this. I'm sure you can hear that. And the motor's not turning. And I was thinking about that. I was thinking, what the earth is causing that? It's wired up the same as it was wired up before. And a thought occurred. Let's try a different power supply. Let me just plug this in over here, out of the way. Get it loosely around there. And plug it into this. Now, this is not connected to the layout in any way, shape, or form, except for the ground, common ground. Wait a second, see if it goes backwards. It's catching in a few places. I need to do a little bit of work on that. I also need to slow it down. But notice what it's not doing. It's not making much noise, is it? And where it's catching is it's rubbing against the brick paper I've installed. I can see where it's rubbing because it's wiping bits clear. Around here, this end here is rubbing slightly. I've obviously got to change the speed on this a little bit and reduce the number of steps. I need to. It's currently on 1600. Basically, I can put a couple of jumper wires on here on this little thing, and I can change that. Just going to turn that off so that it's not rubbing on things. So I've got a little bit more work to do on it. Essentially, I'm going to take the deck out again, and I'm going to go at it with a file, and I'm going to make it very slightly shorter, and then it won't rub. Minor job. I've also got to put the guardrails on, but I'm going to finish making it work just as in rotating. And all I want to be able to do is rotate this back and forth for now. That'll tell me that mechanically this is sound. Then the rest of it's software. But that's just a quick little update on this. It's sticking in a few places. I can see where it's sticking. It's not hard to work out where it's sticking because you just rotate the thing round and you can feel it's like it's binding there. And over time, it will actually rub through the brick paper, which I don't want it to do. So I'm going to take the deck out. I'm just going to... There's two I-beams underneath it that run the full length. I just need to knock them back just a little bit. It'll be 30 seconds work with a file, so that's not a massive problem. I can then finish the paint on it as well, because when I originally put this in, I hadn't quite finished the paint. And then that was when I realised I think some of the araldite hadn't been fully cured. So when I put it all together and when I tightened it all up, oh dear. Then I came to undo it, and it's like, this doesn't want to undo. Right, I'm just going to unplug this supply. So, what on earth is causing that? I suspect it is electrical noise on the 12-volt line. Now, I don't know if anybody else has used a stepper motor with a TMC 2209 and has had that problem, but without changing any of the wiring, a new power supply, and all of a sudden it works. Yeah, let me know if you found out what was wrong with it. There's a few potential fixes for that. I can put some filtering and some smoothing on the 12-volt DC line. Not hard to do, actually. It's DC, so I can stick in a diode, suitably powerful diode, one that can cope with a couple of amps, and a smoothing capacitor, and that should sort it out. I'm probably going to try that. The fallback, and this is a really, really simple system, it works with a separate power supply. So what I'll do is I will run a socket to over here. It'll just be an extension lead, a single point extension lead, which I'll plug in where that was plugged in. I'll just give it a separate power supply. I mean, yeah, it's simple, really. But that's working. A little bit more, I'm happy. I'll do more with the turntable when I've got the code working and I can play around with it. So then, that's been this little update. These ones tend to be fairly short, these Saturday videos. Basically, this is what I'm doing on Friday night. Maybe a little bit of Thursday evening, by the time I get back. But in this one, what I've looked at, a test board for those PCF8575s. So I can now test the other ones I've got before they go in. And the ones that don't work can go straight in the bin. Because what I don't want is ones that don't work loitering and then trying to use them for something. So yeah. And we've had a little update on the turntable, which now turns. It's coming apart again, and I'm going to be investing in a little bit of time with my friend here. Then it's going to work a bit better. I'm going to have a play with the electrics on that as well. I'm going to try and put some filtering in on the power supply. I want to see if that makes a difference. Because if it does, I found the problem. Anyway, this has been Leopard Street. As usual, likes, comments, shares, more than welcome. I've had various comments which I've been trying to reply to. I'm going to do a roundup of people's comments. I'm going to do a video on that, just how we're looking at it. Keep them coming. I do read them, and there's been some. Somebody suggested instead of all the messing around I did with the turntable, why didn't I use a stepped hole cutter? If you've never seen one, it's like a cone, and it'll drill a 10mm hole, an 11mm hole, 12mm, and it's brilliant if you've got an existing hole that you need to make larger, but you need to keep the same center point. Flash of the blindingly obvious. I've used those things before. Didn't occur to me. Otherwise, I'd have bought one and used it. So yeah, thanks for pointing that one out. I know now. I'll probably get one actually at some point, just so I've got it. But that's it for this video. So I'll be back in the future, possibly with more cat-related shenanigans if she comes down here. She's taking her internet stardom well, by which I mean she's asleep. Anyway, catch you in the next one. Thanks very much for watching. Bye.